Okay. I'll assume I'm alive now. I'll give 5 minutes for people to come into the stream so that we can start. Okay, so Yunus Isafari, welcome. Uh, we're still waiting for some more people to come into the stream so that we can actually start. I'm giving out a 5 minute waiting period for me to start. If you can hear me, please let me know so that I know my audio is fine. So just let me know if you can hear me, then let me know if my audio is fine, and then we can make arrangement for me to start. All right. So from the look of things, you can hear what I'm saying. That's lovely. Okay, so we have 1 minute to go before we continue. Um, I'll continue very soon. Okay. Good afternoon, everyone. I hope you are all doing well. If you can hear me, please post it on the comment section that you can hear me so that we can be able to commence the class. Um, I have posted your I've posted your slides. Sorry, I've posted some videos for you to watch on the learning platform. I believe most of you must have seen it. I've also posted sorry, I'm going to project my screen so that you will see what I'm doing. I pray it doesn't misbehave like the last time when we held our class. It kept giving me some funny excuses. Okay, so I believe you can see my screen. If you can't see my screen, then please do let me know. For now, I want to log into my device so that I can be able to see your comments while we hold the class. Okay, so in today's class, we'll be talking about. Sorry, I'm trying to find somewhere I can put my phone so that it will stay, so I can see clearly and it will stay just fine. Okay, in the previous class that we held here on campus, we discussed on things like components that constitutes a computing cluster. Now, based on that, we itemize some of the things that we'll be needing to create our cluster, which include things like a switch, things like RJ45 cable, things like Raspberry Pis, and so on and so forth. Now, in this particular class, we will discuss on computing cluster software. Now, what is a software? And what type of software do we have? Now, a software is a set of instructions that tells a computer what to do, when to do it, and how to do it. Practically, what to do, when, and how. Now, a software is written by people called programmers, and there are many types of software, but the ones we are most concerned with is, or the one we're most concerned with is the system software, and then subsequently we will discuss on the application software. Now, I have posted a quiz. Let me go through it quickly and see how many of you have attempted it. I have posted some materials on this platform for us to be able to catch up to what we want to do in the class. Let me check quickly. Emphasis, cluster. supercomputing cluster. Now, in the last week class, I posted some videos for you to watch. I don't know if most of you have watched the video. I posted a quiz for you guys to do, and so far only one person attempted the quiz. Now, I find it sort of, like, we post these things for you guys to do so that we can be able to assess you at the end of the program. But usually we get complaints after the time has elapsed. After the time has elapsed, that is when we get to hear people coming to tell you, sir, my phone got misplaced. I was not able to do the quiz. Please help us talk to the facilitator to open the quiz for us to do. Please try as much as possible to go through your quiz and do them as at when due, so that you don't become a victim of I'm sorry, sir. Okay. Now, for this particular class, like I said, we are going to discuss on computing cluster software. Okay. So, like I started explaining, we'll discuss more on the on the system software for now, and then subsequently we'll discuss on the application software. Now, building a computing cluster with Raspberry Pi is an exciting project. The choice of operating systems depends on your specific use case. Now, there are many use cases for a computing cluster, especially for what we are trying to create right now. Some of the things you might be looking into might include things like, are you trying to create this cluster for education purpose? Are you trying to create the cluster for things like testing a web application? Are you trying to learn how to create maybe something like IoT? Are you creating a computing cluster for IoT, or what is your use case? So depending on your use case will determine the type of operating system you will use. Okay, but generically, you have the official Raspberry Pi operating system, which is the first one we're going to discuss. Raspberry Pi OS, formerly known as what? Raspbian. Raspbian is generally best for general use and compatibility. Why is because Raspberry Pi OS is the official operating system of Raspberry Pi, so it is highly optimized and well supported. Think of it this way: imagine you go to a tailor and he takes your measurement and he sew clothes for you, or he made clothes for you to match. It will be far better than a situation whereby someone described you to him and then he sewed the clothes. So this is the official operating system for Raspberry Pi. Raspberry Pi. So because of that, it is highly optimized. It has a large community and extensive documentation, which is helpful when setting up a cluster. Recommended for beginners to intermediate users, general purpose tasks, and standard cluster setups. How do you install it? You can install it using Raspberry Pi Imager, or download the official image from Raspberry Pi website. What are the key features? Built specifically for Raspberry Pi. That is one of the key features. Regularly updated and secure. Okay. Includes many utilities and software packages. So because it has a large community, a lot of members of that community create software packages that will allow you to simply call and use those packages without having to go through building them yourself. Use case, general purpose computing, small scale clustering, and educational purposes. Now, those are some of the use cases for a Raspbian. Okay. The second one is you have things like Ubuntu OS. Okay. You have things like Ubuntu OS, Ubuntu Server, or Ubuntu Server, which is the Raspberry Pi version of it.
No, sir. That's your comment. You put in all the necessary files.
Which are the necessary files? Okay, all the best. Okay. Best for more advanced use cases, more advanced use, cloud, and containerized workload. Why is because Ubuntu is well known and widely used Linux distribution with excellent support for Raspberry Pi. It's, the operating system itself is lightweight and works well for setting up a more robust cluster. Now, an example of those containerization include things like Docker, Kubernetes, or machine learning tasks. Okay. Now, for a beginning, for a starter, we can do Docker and Kubernetes, and then in the future we'll look at other aspects of computing cluster. Okay. This is recommended for intermediate to advanced users, especially if you plan to deploy containerized applications or services on your cluster. Okay. Installation, you can download official Ubuntu server image for Raspberry Pi from the Ubuntu website. What are the key features? Great support for cloud applications, Docker, Kubernetes, and DevOps tools. Long-time support release with security update of up to 5 years. Easy to set up and manage with apt package manager. Now, the difference between the Raspbian and Ubuntu server is that with apt install, there are a lot of packages you can be able to pull from Ubuntu Cloud and install on your own machine, and that will allow you to do a lot of things. Okay. Now, what are the use cases? If you want to create things like hosting services, cloud computing, containerized environments like Kubernetes and Docker, if you want to run a large distributed application, you can use this particular operating system, which I think is what one of the operating systems we'll be using for this particular class. Then you have HyperIOTOS. This operating system is best for containerized and Dockerized based cluster. Why? The reason is because it's a minimal Docker focused OS that is optimized for Raspberry Pi. Now, you will hear me talk about Docker and containerization a lot during this class. What it means is simple. Imagine you develop a software or you develop a piece of software, and you want to be able to move it from one computer to another, or from one operating system to another. Now, previously, when we were still learning how to program, it's very, very possible for you to develop an app, and when you go to deploy the app, you get to realize that it's not compatible with the operating system that you're trying to host the app on. I have had that experience severally, where I will develop my app using Windows, and Windows MySQL does not care about camel casing. As a matter of fact, it converts your table names to a smaller case names. But then when I want to host it in Ubuntu is very, very much case sensitive, especially in MySQL, and my application keeps crashing. As a matter of fact, at some point, I had to do an entire app because of this particular problem. Now, with Docker, what it does is it allows you to build the app and then you ship it as is, such that it will not break, it will not have any problem. All the dependencies and all the other packages that you will need to run the application will be on the Docker itself. Maybe during one of the practical aspects of the classes, we will look at Docker and Dockerization, so that we can be able to look at the possibilities that comes with Docker and containerization. So this particular OS is Docker focused. Docker focused operating system that is optimized for Raspberry Pi. It allows you to set up Docker on your Raspberry Pi cluster easily and quickly, making it ideal for containerization. Now, we might develop our first container using we might develop our first cluster using the Ubuntu server, but we'll come to this and then we'll look at the differences and the experiences we will have doing installations and run two systems together, run two systems, so that we can be able to assess which one is easier and which one is faster for us to be able to do, and so on and so forth. Now, which type of user is it recommended for? Users who want to set up a containerized cluster using Docker or Kubernetes. Okay, installation. So you download from the Hypriot website and flash it to your SSD, to your SD card. Okay. Key features is pre-configured Docker installation, small footprint, optimized for IoT and edge devices. Now, there are many types of computing, and one of them I think is edge computing. At your own time, feel free to go and check that out. But for now, to be out of the context of this particular class. Support Docker Swarm and Kubernetes out of the box. So because it's optimized for Docker is Docker focused operating system. Out of the box, you will have Docker and Kubernetes. Okay, use cases include things like containerized apps, microservices, IoTs, and edge computing. Okay. Another operating system that we will look at is Kubernetes itself. With Raspberry Pi OS or Ubuntu server. So best for Kubernetes clusters. Why? So Kubernetes is there is a abbreviation for it where you have K3S, which is Kubernetes. It's a lightweight Kubernetes distribution designed to run on resource-constrained devices like Raspberry Pis. It's a great option for building a Kubernetes-based cluster on your Raspberry Pi setup. Okay, recommended for intermediate to advanced users who wants to create Kubernetes clusters with Raspberry Pi. Installation: you can install Kubernetes or Raspberry Pi OS or Ubuntu server using commands. So subsequently, we'll be looking at the commands you use to install Kubernetes on your Raspberry OS or the server OS. Kubernetes made lightweight for IoTs and edge computing, easy to deploy and manage a Raspberry Pi cluster. I'm sorry, my power just went out. I think it should be back in a jiffy. Easy to deploy and manage on Raspberry Pi cluster. Great for scaling workload, running microservices or cloud native applications. Use cases: Kubernetes, container orchestration, cloud native applications, and scaling workload. Then there is the Diet Pi. Okay, there is the Diet Pi. Now, Okay, so usually I get power back before a minute, and it's been I'm surprised that the power was not back up till now. Okay, so we have the Diet Pi OS, best for low resource or minimal installations. Why? Is because Diet Pi is a lightweight Debian based OS that's optimized for low resource devices. It is great if you want minimal overhead and to keep things very lightweight in your cluster. Recommended for users who need a minimal OS with fewer pre-installed packages and lower resource usage. Installation: download the Diet Pi image from their official website and install it on your Raspberry Pi. Key features include things like it's very lightweight. That means it's not heavy. Highly optimized for low resource usage, meaning that it will not consume a lot of resources. Say, for instance, um, if you have things like your Windows, where when you check your task manager, you see maybe your hard drive is at 100%. So this is not like that. This it consumes minimum resources and can be used for various purposes like media servers, like Internet of Things, lower power cluster nodes or low power cluster nodes. Use cases include things like edge computing, media servers, low power clusters, and minimal setups. Those of you online, if you can still hear me, can I see you say something so that I know that I'm not just talking to myself? And those of us online, if you can hear me, can I see something? Okay. Okay, so it turns out that I can hear myself from my phone because I'm looking at the comments, and I think we can continue so that we finish on time and move to other things. Okay. Another OS is OpenHabian OS. Okay, for IoT clusters. So how many of you know what a smart home is? Is the question, because if you don't know what a smart home is, then you hardly know what IoT stands for. Though IoT extend above smart home, but it's the easiest way to explain what it is. For the smart home is a home whereby most of your electronics are being controlled remotely, or you can control them remotely. Now, previously, when we discuss with friends, and we tell them, when I was in school, I used to see a gate that doesn't require you to come and open it with your physical hands. You can just use remote control. Be like, no, Haba, why will you be lying to us? That how will you tell us that a gate opens itself? But then, of recent, I've seen multiple places with automated gates and what have you. Now, that is an example of a smart home where you don't need to do things manually. You have homes that when you come into, the light automatically comes up. Air conditioning start itself automatically. Television start itself. You have things like Siri and what have you, that you can tell to maybe play a certain audio for you or a certain video for you, and you'll be seated and it will start playing the movie or the video or what have you. So that is an example of a smart home. Okay. If you are building an IoT-focused cluster, e.g. for a smart home automation, OpenHabian is an optimized OS for running OpenHub, a popular home automation platform. Okay, it's recommended for users specifically looking to build an IoT or homes automation setup on their cluster. Download the OpenHabian image from their official websites. It's a process of installation, and then you flash it to your SSD card or SD card. Now, during the practical aspects of this class, which is coming up on Saturday, we will actually start building our cluster. We'll start building our cluster, and we will start building our cluster, and we will build. We will do the setup and install all the operating systems on each of our cluster, on each of our node, and do all the networking. Maybe we'll do networking on that same day, or the next class we'll do networking. Installation. Okay, so we're doing installation. Key features optimized for home automation usage include many pre-configured services, great for managing smart home devices across a network, useful smart homes, IoTs, and home automation. Then you have Fedora IoT. Best for IoT project with Fedora ecosystem. Fedora IoT is a variant of Fedora optimized for IoT devices like Raspberry Pis. It's a solid choice for those already familiar with the Fedora ecosystem, or for projects requiring Red Hat based systems. Recommended for intermediate users, especially those already familiar with the Red Hat or Fedora ecosystem. Now, I have not used any of these two operating systems before. It will be a good project to have a taste of it. So maybe one of our classes will do the installation and do the configuration, and then look at the possibilities within this particular operating system. Download the Fedora IoT image from their website. So we're going to download the image and maybe flash it to our SD card. Key features: built-in security and update from the Fedora ecosystem, suitable for IoT applications, open source and community driven. So that means this operating system is open source and is community driven. And the use cases are IoT projects, containerized applications, security focused cluster. Okay, not that the rest of the operating systems that we've mentioned so far, they're not secure, but this is security focused. Okay. Okay, so I think this is the last slide. I will give room for discussion. If anyone has any question, please feel free to ask. For attendance, I think I'll do a screen grab of just post something, and then I will do a screen grab, and then I will get back to you on that. Okay. All right. Okay, so in the absence of questions, I think I will call it a day. Thank you very much for hanging out with me here on this platform. In the next class, we'll discuss we'll do the practical aspects and do the installation and do the configuration, and then maybe test one or two things to see how it works. And then you get necessary experience. And please endeavor to go and do my quizzes. This is the quiz that we're going to submit to the sponsors of the project for them to know that you are learning new things and that your certificate actually carries. There's a process for you to acquire that certificate. Thank you very much and have a lovely afternoon.